Here we will see understanding stack memory in C#. The stack is a region of memory that is used to store local variables and function call information. It is called a stack because it behaves like a stack of items, with the most recently added item being the first one to be removed. That is last in first out. Each time function is called, a new block of memory is allocated on the stack for that function's local variables and parameters. When the function returns, this block of memory is deallocated and the stock pointer moves back to the previous function's block of memory. One important property of the stack is that it is very fast to allocate and deallocate memory from it. This is because the stack has a fixed size and the memory is allocated and deallocated in a last in first out manner. However, the stack has a limited size and can only store a finite amount of data. If the stack grows too large, it can cause a stack overflow, which can lead to crash or other unpredictable behavior. For example, here we have defined a method with two integer variables as x101, y102, and we have created the object for the class name. When the first statement is executed, the compiler allocates some memory in the stack. The stack memory is responsible for keeping track of the running memory needed in your application. That is, first it will assign a memory for x equal to 101 in the stack. That is, it will assign memory for x equal to 101 in stack. When the second statement is executed, it stacks its memory allocation on the top of the first memory allocation. That is, memory allocation for variable y is allocated on the top of the memory allocation for variable x. The stack memory allocation and deallocation in .NET uses the last in first out principle. That is, memory allocation and deallocation are done only at one end of the memory, that is top of the stack. When third statement is executed, it internally creates a pointer on the stack memory and the actual object is stored in the different memory location called heap memory. The heap memory location does not track running memory. Heap is used for dynamic memory allocation. That is, when statement 3 is executed as class name cls1 equal to new class name, the object CLS is stored in heap memory and the variable CLS1 with reference address is stored in stack memory. The reference pointers are allocated on the stack. The statement class name CLS1 does not allocate any memory for an instance of class name. It only allocates a variable with the name CLS1 in the stack and sets its value to null. And when it hits the new keyword, it allocates memory in the heap. When these three statements are executed and the control will exit from the method, when it passes the end control, that is end curly bracket, it will clear all the memory variables created on the stack. It will deallocate the memory from the stack in a last in first out fashion, but it will not deallocate heap memory. Later, the heap memory will be deallocated by the garbage collector. Key characteristics of the stack memory are allocation. Stack memory is allocated for static memory allocation and local variables. It is managed by the CPU, which makes it faster and more efficient since it involves simply moving the stack pointer. Usage. When a method is called, a block of memory is allocated on the stack for its local variables and parameters. When the method call returns, the block becomes unused and can be used for the next method call. Lifespan. Variables stored in the stack are only available during the lifetime of the method call. Type of data. It stores value types in C#. These include primitive data types like int, double, char, structures and references to the objects. That is, the reference themselves, not the object. Limited size. The stack size is typically limited and exceeding this limit can lead to a stack overflow, which makes it suitable for managing small and short-lived variables. Automatic management. Memory on the stack is automatically managed and you don't need to explicitly deallocate this.